having these gaps. It's also a pretty short talk, so the idea is that if we were there in person, this would be a lot more interactive, and we could all sort of chat through things as we go. So please don't hesitate to bring something up, butt in, interrupt, and we can hopefully be a bit more helpful that way. I'm not sure if I'll be able to. I'll try and keep an eye on the chat, but if anyone just wants to unmute themselves and talk, then I can address questions as we go. So just to, like I say, a lot of this will already have been covered. I figure it's worth repeating some of it. And just so you understand who you're talking to and when, and who's actually going to help you and when, I wanted this slide in there. And Amber gave you a pretty good idea of what the operator does. They are not a scientist, so they are at the telescope and they are looking after the telescope. That is what they do. The operator does not care about your baselines. They aren't going to advise you on any scientific decisions. Even if they were able to do so, some of them would be able to, some of them might not be able to. But that's not their area of expertise. It is up to you to make sure your data quality is decent, or at least you might not be expected to fix the problems, but it's up to you to check that the data coming in are of reasonable quality. And if there's a problem, then you can tell the operator, and then they will be able to either call the on-call person or your project friend or someone. Which brings me to the project friend. So this is a person you would normally have contact with before you start your first observing run. And we usually try and assign people to projects who have vaguely similar scientific interests, and usually in the same frequency range. The staff scientists at Green Bank should be able to help you with any frequency receiver, but normally we're expert in one or two, and we're normally assigned as friends to those areas. So we can give you the best advice on the calibration methods and the data reduction and so on. However, that project friend, again, is not responsible for your scientific decisions. So, we can help you find a good calibrator and so on. But in terms of what's, we can give you some advice on the switching methods you should use, things like that. But ultimately, it is up to you to figure out what it is you're trying to get from your time and so on. And we all take turns. We're on a rota to be on call for the telescope. So if something breaks at 3 o'clock in the morning, and you're getting terrible baselines, say, and you just can't figure out why, then the operator will call the on-call person, and that could be any scientific staff member, so either a scientist or a data analyst, and they will try and help. And if they can't help themselves, they will know who to call. So the project friend and on-call support scientists, sometimes the lines get a little blurred there, because your project friend is in constant contact with you leading up to your project, but then the on-call person will be the person you speak to on the night. And then if you need someone present the first time you observe, maybe even the first 2 sessions you observe, then it will be the on-call person normally who will sit in with you and help you get started. That's not always the case, but it depends on the complexity of the project and so on. And it's the on-call person who you'll speak to if something goes wrong. So you may not know who they are before time, whereas you should hopefully know who your project friend is. Yeah, so in terms of getting help, if you're in the lead up to your first observing session, it's your project friend who you'll be in contact with, usually via email, and then they'll help you write script. Normally you write your own scripts and then you iterate with your project friend to make sure that they're correct. They can just be a quality checker on that. You will only be talking to the on-call support scientist if you need that extra support on your first setup or if something breaks during your observing run. I've put up a couple of links here for the help desks. We have 2 help desks. Helpdesk-gb at nreo.edu. That's essentially for our computing IT group. So that's if something's wrong with your system. You know, there's some software that's not working, or you're not able to log in, or something like that. Hopefully, we'll get all that sorted out today. But yeah, helpdesk-GB is not really meant for more scientific questions or anything like that. It's just if something's actually not working on the system itself. We actually have this new observers help desk, or at least rejuvenated observers help desk for more general questions. And at the moment, it's still not quite completely clear to me when you should talk to your project friend or when you should go to the observers help desk. Your project friend can normally at least point you to the right person for any issue you might have. But a more general issue that isn't actually directly related to your observations is probably better to go to the observers help desk. Especially, the main use for that so far has been in proposal writing, when people are trying to get something figured out for a proposal that they're writing. So you're all currently going through the process of getting an account, and yeah, so I won't spend too much time on this. I think you've probably already been told that the account will be active for 2 years. I think that's from the last time you log in. So if you haven't logged in for 2 years, that account will be archived. If you have a problem, if you haven't logged in for 2 years and you still need to access that data or access the system, then you can contact the help desk, the email address I gave in the earlier slide, and they'll be able to help you reactivate that. So yeah, we've just been going over the FastX logging in method and so on. And you'll all be pretty familiar with this by the time you're through with this school. And I'll try and I'm going to just change my screen in a minute. We can log in and we can go through some things on there. I saw someone in the chat that was saying that they might prefer to use the Vnc method. We have instructions for those at this link. These slides will be available after this. They're already on the site, and I'm sure we'll be circulating links to the PDFs. So don't worry too much about copying these links. Yeah, we have full instructions for accessing the system with Vnc there. It's a bit more complicated to use the Vnc, as I've written here. If you don't know why you would want to use the Vnc method, then don't. It can be more useful, especially if you're getting a lot of clear screens up, something like that. But for a lighter project, for a less complex project, then you probably don't need to use it. As was mentioned earlier, you're not going to have control of the telescope until the operator puts you in the gateway. I don't think I need to sort of linger on that any longer. One thing we've found with our schools is that there's not as much familiarity with Linux as there used to be with the people attending the schools. So I was just going to spend the next few minutes covering the Linux system itself, and what you do when you have a terminal window, and how you actually move around in that system and operate that system. A lot of you are probably already a bit familiar with this, so I'm not going to spend too long on it, but just in case there are people who haven't had any experience with it at all, I thought I'd give you enough to get started. So we normally start a terminal through a GUI, and there are also actually different types of Linux, so that can make things a little more confusing. But once you get logged in, and as we were doing in the last session, you all logged into FastX, you see a window like this. And you can then just click on this terminal down here. I'm hoping you can see except it's not a real window. You can see, I'm hoping you can see my mouse cursor. So this is the terminal there. Now let's see if I can share a different screen. Stop sharing and I'll reshare. How about that? Okay. So here I'm logging into FastX. And normally you come here, you launch the session, and as has been mentioned, there are these different machines available. Arial and Titania should only be used for observers actually observing. Most of the time, there's this, there's two other, if you're not actually observing, there's probably two reasons you're logging in. One is to just check that your scripts are present and so on, maybe do some light script editing, or you're going to do some heavy data reduction. So if you're doing the heavy data reduction, the machines you want to use are fairly obvious here, the Fourier, Euclid, Thales, Planck, and Newton. If you're just logging in to have a look around, check on something, do some script editing, use this XFCE and launch that session. And we'll get this window up here. And then we can click on a terminal, and here we are. And then just moving around the system is fairly easy. So just to begin with, just to look at what you have in your current directory, you can type ls, which just means list. And that will list the documents, and there's several caveats to that. So they'll show you the files in your home directory, and you have two main regions you'll be working in. This is your home directory, as I said, and that's actually along the path users and then your account name. You have another directory in your Scratch area, which is under home, Scratch, and then your username. And that your home directory, which is the one you're in by default when you set up a terminal window, has a 20 gigabyte limit. And so you're not meant to keep huge data sets in there or anything like that. It might be a good place to keep your figures and anything like that you're working on there. And it's definitely a good place to keep your scripts when you're first working on them, because it's backed up. And so if something gets deleted or changed, we can go back and track that. In the home Scratch area, while you have a more or less unlimited data quota, that area is not backed up. So you need to be a bit more careful with what's going on there. And that's fine for something like your basic data sets, because we archive the data you've actually taken. So if you lose something from your Scratch area, we can always recreate those data sets. Oh. As I said, there's a lot of Linux commands that are very useful, but what is most useful is knowing how to explore those. So most commands will have a help or man page, which will give you some more information on them. So the ls just gives you that, but I like to use this ls minus LART, which gives you a lot more information, and finding out what those, we call them flags when you attach an extra command to that. If you type man ls for manual, it will give you the manual entry on ls, and it'll explain in a lot more detail how to use these commands. So I'm rushing through this, but the idea is that you should be able to go back to my slides and pick up this information again, and that you're going to need to spend some time on your own digging around on the system, so if you're not already aware of some of these. There are some other commands that are going to be very useful to you. pwd gives you the path of your working directory, so that shows you where you are. cd means change directory, and so if I want to change to my Scratch area, and type it all out there, and here I am now in my Scratch area. If you want to create a new directory, you want to start writing some scripts, you can type mkdir, make directory. Now I have a new directory called temp where I can put some scripts or something. And you can do an rm for that directory, or rmdir. This .. dash I just typed takes you up one directory. It's the equivalent of clicking an up arrow if you were in a Windows environment. and then CP and then V mean copy or move. And several times in Linux, you'll find that some of these commands don't always work the same way on a file that they would on a directory. So if I was trying to copy a directory, that's not going to work because it doesn't like to do that on a directory. It only likes to do that on a file. So you need this -R flag, which means recursive, and then it will do everything below that tipping directory. There's usually a --help flag or the man page that I talked about that will help you find more information. Another command is pretty useful. So I just, this was taking a long time to copy that directory. I don't actually need to do it. So I actually stopped that by hitting Control-C to cancel that command. If I started typing something and I think, oh, actually, I don't want to do what I typed there, but I also don't want to delete that whole line, I can hit Control-C. That'll take me to a new line. A command I find very useful is called apropos. And that helps you find command, you want to do something, but you have no idea what the command might be to do that. Let's say I want to open a PDF document. I can type apropos PDF, and there's 150 scripts or applications that have something to do with PDFs there. So here, show a printing preview of PostScript and PDF documents. So events is what I'm looking for. And that will actually take me to another very useful thing that you may not be aware of in Linux. If you highlight some text and then middle click, it will copy and paste that text into your command line. I have to actually supply a command. No. I don't know where I have a PDF file off the top of my head, so I will leave that for now. But there's many more commands, and especially if you start writing shell scripts, a lot of these commands are going to come in very handy. So zip and tar are compression algorithms. If you want to know how big a file is, we have this disk usage command, and putting the -H puts it in human readable units. So if you were to just type du, and let's say, let's have a look at some of my data. I don't actually know what units that's in. It may not be that handy. So if I put this -H, it tells me it's 15 gigabytes for that whole directory. Hopefully, and then we can. I'll leave you to discover more of these on your own, rather than giving you an exhaustive list of all the Linux commands you can use. If you're not familiar with Linux, some tips you may need to be aware of is to avoid using spaces in file names or directory names, because Linux will interpret that as two separate directories or files, or even if it doesn't, it still won't name them very well, and you'll have to put in a special character to account for the space. So hence why you'll see a lot of file names with underscores or dashes in them, but then dashes can also be problematic, so something to be aware of. The up arrow is very useful in Linux. What I'm doing here is hitting the up arrow, and it's cycling back through all the commands I've typed in this window so far. So it saves you a lot of typing, especially if you've got a long directory name that you don't want to type out again and again, or that you can't remember exactly every time. Another very useful command is Control-R, which will give you the ability to search back through the commands you've written recently. So if I start typing something, it will give me the matching commands that I've typed, and hitting Control-R again will give you, will cycle back through all of the matching statements. Something else people aren't always aware of is being able to double tab. So I have a directory in here called SOF 09104. But if I couldn't actually remember what that whole number or that whole thing, I can hit the first two letters. And if I hit tab twice, it will auto-complete, or at least show me the options of what the matching cases are. And then once that's actually completed, it'll show me what's in that directory by double tapping. Something someone mentioned is that, if you type Astrid and hit go, hit return, this will now start an Astrid window, and it'll take a little while. But this is now tied up my terminal window, and I can't really do anything else in that window. So I either have to open a new tab or a new terminal. You can actually get around that by typing Astrid space ampersand, and then that will open Astrid, but also return control to your terminal window. If you fail to do that, you can actually hit Control Z and suspend the software. This software is now unresponsive, but I can then type BG for background, telling it to put the app in the background. And now I have access to my terminal window and to the software I started. I'll keep moving. I'm running out of time a little bit. So you've already covered Astrid, Clear, and well, I guess we haven't covered GBT-IDL very much yet. But yeah, Brendan and Amber did a pretty good job of covering Clear and Astrid. So I'm not going to spend too much time going over those. GBT-IDL is going to be covered by Pedro if you're a spectral line observer. And if you're not, you may not be using it at all anyway. So some tips on these applications, though, is that the Clear documentation is actually pretty lacking, but there are good help files. So while there's not a good set of web pages for Clear, if you have a particular Clear application, then you can normally type I think -help, yeah, and that'll give you a bunch of extra information there. Yeah, I think I've covered most of this. So, yeah, so just a tip on Astrid. I actually was in and out of Bren's talk, so I'm not quite sure what she covered and what she didn't. This is just a personal recommendation when you start observing on the GBT. In our observer's guide, we tell you to put your configuration in your scripts. Sorry, we tell you to put them in a separate file on the system and then to exec file to read in those configurations. Actually, I would not recommend doing that. It's just my personal choice is to put the configurations in the scripts. And this is because when you run a script on Astrid, we log what is in the scripts. And so if we're going back and trying to figure out, what might have gone wrong with some data in the past, if that configuration is in the script, it makes it a lot easier to retrieve, because if there's a separate file on the system with that configuration in it, we don't know if that might have changed at some point or been moved even. It happens quite a lot. Something to point out and to remember is that Astrid is essentially a Python notebook. So while there's a lot of classes and functions that are pure Astrid, it's really Python that you're writing. So if you remember that and you know Python, it can give you a lot of leeway to personalize your scripts. You may or may not be aware that what's happening when you're observing is that your data are being filled into this data structure called an ST-FITS file. And depending on your data rate, there sometimes can be slips in that. It will do its best to keep up with the observing. And if that means having to jump over a few scans, it will do that. And so you may want to refill your data after your observing session. It's something you should talk to your project friend about. I'm running out of time pretty quickly, so I'm going to skip ahead a little bit. As with everything else that I've mentioned, you can usually type -help or --help to get options and look for various help there. One more thing I wanted to bring up before I finish is we have this Gbt Gridder. If you're doing mapping observations, you're going to either want to use the Gbt pipeline or the Gbt Gridder functions. And they're very useful tools, but Gbt Gridder actually has some poor choices used for the default methods. So this is currently being addressed. We're actually in the process of updating Gbt Gridder and should be massively improved. But again, you should talk to your project friend if you have any questions about that. So it's a bit of a whirlwind tour through the Gbt system, but I'm happy to talk to any of you and answer any questions you may have. See if there's anything in the chat. Let me stop sharing now. No, I don't see anything. So if there's any questions you'd like to ask, then just unmute yourself and go ahead. So there's a question, what is Gbt Gridder? So I was sort of rushing towards the end there. So if you're performing mapping operations with the Gbt, Gbt Gridder takes your individual spectra normally. Well, actually, I think it only works with spectral data. I may be wrong about that. But it'll take the individual spectra from each telescope position and combine them into a data cube. So your final product, your FITS cube, is created by Gbt Gridder, if that's the reduction method you use.
Just a note that we will make sure that we have all of Larry's slides available by the end of today in case you want to go back on your own time and poke through any of these. Any final questions for Larry? If not, thank you very much.
Okay, thank you.